You ever wondered what exactly is the difference between ordered and unordered collections in Python? So what I have done is I have created these two example, although I should not call this list but rather set. Okay, so I have these two examples in which the elements are same, but one is called ordered, another is called unordered collection. Both are collections. Collection is something that you can put items into. In this case, in the Python collection, what we can do is we can put several data types into it. So in one word, the difference is that ordered collections remember the insertion order, whereas unordered collection do not remember the insertion order, but rather they rely on the internal hash mappings to kind of so what this means is there's this thing called hash randomization. So each time you print your set, it will be randomized printing. So either you print it or you loop through it, you will get in each loop a random set of characters from this collection, this unordered collection, because there is no sense of internal ordering. So you can think of this as a box where all the items are just put inside it and no recollection of any ordering is there. Whereas in the list there is a collection, and the side effect or rather effect of that is that in ordered collection we can index those type of collections, whereas unordered collection we can't index those. So let me quickly spin up a inbuilt Python interpreter ideally, and let me paste these two examples here. So I'll just grab this ordered list and run this. Okay, and let's now grab this as well and print this. Now let me try to print ordered list example. You see the order is maintained, and if I just use this and access the first element, I know that I am trying to access this one element, and that is why list has to maintain this internal ordering, because indexing works with list, so that whenever we try to access a certain element at a given position, we are telling Python that we want to access this element only, so don't shuffle these inside. Whereas in the unordered, if I print this, you see this order is shuffled and it's not fixed. What do I mean by it's not fixed? It means that now if I run this, it will be same. It will be same, but let me do one thing. Let me now copy this and just close out this interpreter, and let me open the interpreter again. So if I again paste that same set and print this, you see the order is different. Earlier it was starting with E, but now it's starting with P. So it works with some sort of hash randomization, and it computes hash value of these, which are inherently random in nature, and that is why this ordering is basically not maintained for a set. Okay, now you might be wondering why someone want to implement such kind of functionality, and the reason for that is because when you are trying to insert something in order, it's not necessarily very fast data structure, whereas unordered, so if let's say I check something like A in unordered set, then it's true and it's quite fast, okay, because it's based on hash values. Whereas if you do the same operation for a list, it will be much slower. Now you might be wondering that I don't see the difference. It will be visible when you are dealing with, let's say, millions of or billions of items in a set or a list. Okay, so currently our set or list contains only 5 elements, and that is why this difference is not very apparent. So just to summarize what we have talked about is set is a unordered collection, whereas list is a ordered collection. Okay, list is a ordered collection. Now set is a unordered collection and list is a ordered collection, and set does not, so direct effect of being unordered is that set does not support indexing. Okay, indexing. And what this means is, if I take my set example and if I grab the first entry, it won't work, because it knows that I don't know what the first entry means, because internally it just puts all the elements as a random items in a box. Okay, I hope it makes sense. So in this video we talked about the difference between ordered and unordered collection, and how the direct effect of being unordered is that set does not support the indexing. What are some other ordered or unordered collection examples? So list is one ordered example, and now dictionary is also ordered. Although dictionary used to be unordered prior to, so if I look at less than 3.7 version, dictionaries used to be a unordered thing, and then ordered thing. Unordered thing, but now it's ordered. Okay, now because there was a demand that dictionary keys are preserved when we loop through those. Okay, so that is why they are now ordered. What are some other examples? Tuple is another example which is ordered. So hence tuple also supports indexing, but tuple is immutable, whereas list and dictionary are mutable data structures. Whereas if I look at, so I'll just print out, although this is just ideally, that is why it is giving syntax error. Okay, so now if I talk about the unordered, set is only the primary example, but there is one more data structure called frozen set. Now frozen set is another example. I can go into depth in another video, but the idea behind frozen set is just an extension of set, and it adds some additional functionalities to kind of freeze certain elements. Okay, so yeah, that would be it, because for unordered we don't have such examples. The only example that you would work primarily in your day-to-day work is going to be set. Okay, I hope whatever we discussed makes sense, and what I'll do is I'll wrap up this video, and I would be looking forward for your feedback, for any comments, or any kind of negative, positive comments that you might have, or feedback you might have. I would be willing to incorporate those in my upcoming videos. So thank you so much.